Hey everyone, welcome back. Today we're unpacking a concept that honestly sounds like it was pulled straight out of a classic sci-fi novel, but it's actually the very real frontier of artificial intelligence, AI that builds AI. So let's dive right in and demystify recursive self-improvement. Okay, let's kick things off with a pretty wild historical statement. The last invention humanity would ever need to make. This was proposed way back in 1965 by I.J. Good. He was a brilliant mathematician who actually worked alongside Alan Turing during World War II. Good was referring to an ultra-intelligent machine that could surpass human intellect, specifically in its ability to design even better machines. This would theoretically lead to a runaway effect he famously called the intelligence explosion. It's an incredibly powerful thought, and it really forms the absolute bedrock of what we're looking at today. Now, hearing a quote like that immediately begs the question, right? Is AI actually building its own successors today? When most of us hear AI building AI, our brains instantly jump to, some Terminator-style machine independently upgrading its own brain in a dark, isolated server room. But let's calmly pivot away from that runaway Hollywood doomism for a second. We really need to ground ourselves in what the top research labs are actually doing right now, rather than what the movies tell us might happen. And that brings us to the core definition for this explainer. Recursive self-improvement, or RSI, is an AI system improving the process that creates future AI systems. Today, this doesn't mean a fully autonomous AI instantly inventing a completely new neural network from scratch in 5 seconds. No way. Instead, what RSI really means right now is the automation of coding, setting up experiments, and handling complex research workflows. It's about AI helping researchers build better foundation models, methodically, step by step. Section 1, the historical echoes. Let's look at the roots of RSI. Because to truly understand where this is going, we have to prove this isn't just some fleeting modern hype trend. Tracing this 80-year-old conversation reveals something fascinating. Back in the 1940s, you have John von Neumann theorizing about self-reproducing automatas. Fast forward to 1965, and we have I.J. Good talking about ultra-intelligent machines. And then jump to today, where modern labs like Anthropic, Recursive, and Sakana AI are taking the first real steps to automate AI research loops. So this is a deep, historically rooted mathematical conversation that's literally only just now becoming engineering reality. Contrasting these two historical giants really helps clarify the intellectual roots of all this. Von Neumann was fundamentally asking, can a machine reproduce itself? He identified a specific threshold of complexity where a machine could theoretically build something at least as complex as itself. But reproduction isn't the same thing as progress, right? Then you have I.J. Good, who asked the ultimate question, can a machine improve itself? Good's vision of an ultra-intelligent machine designing a genuinely better machine is exactly what modern RSI is chasing today. Section 2, the AI research loop. Let's look at automating science. How exactly do we get from 1960s theory to today's modern mechanics? Well, we have to break down this abstract idea of improving AI into tangible, everyday reality. Because here's the secret. Research is not magic. It's a rigorous experimentation loop. Building software and training cutting-edge models requires writing code, documenting tests, and building extensive infrastructure. What modern labs are doing isn't conjuring an omniscient brain out of thin air. They're systematically automating standard machine learning, engineering, and research pipelines. Let's actually walk through what that loop looks like, because it's a very concrete step-by-step cycle. First, you propose an idea. Second, you implement that idea in code. Third, you run the experiment on your computing cluster. Fourth, you rigorously validate the result. And fifth, you learn from those results and rationally choose what to try next. You just repeat this until something finally works. So the absolute crucial point here is that an RSI system's ultimate task is simply to automate these exact stages, operating as an automated research assistant locked inside a closed-loop pipeline. Now, you might be wondering, if AI automates that entire loop, what happens to the human researchers? Ironically, these brilliant scientists are actively trying to automate themselves out of the tedious parts of their own jobs. But this doesn't make researchers irrelevant. It actually just shifts their role up the cognitive ladder. AI takes over the exhausting execution details. Writing the boilerplate code, debugging, running the endless tests. Humans move up the chain. We focus on setting the high-level goals, validating the final outcomes, and governing the self-improvement process. Ultimately, humans decide which conceptual directions are actually worth pursuing in the first place. Section 3. Agents versus true RSI. Understanding the shift. We really need to clarify the fundamental difference between the highly capable AI assistants we use right now and actual recursive self-improvement. Think about self-improving agents for a second. These are open-source task agents like OpenClaw or Hermes. They're absolutely amazing at improving their own prompts, utilizing software tools, and optimizing specific task workflows. But contrast that with True RSI. This goes so much deeper. True RSI improves the model building process itself. It optimizes the underlying training data, invents entirely new neural network architectures, refines the mathematical training methods. It essentially builds a functionally stronger successor. It is the profound difference between automating a task and automating the creation of intelligence itself. Basically, we need to think of RSI not as a binary on and off switch, but as a spectrum of decreasing human involvement. Level 1 is kind of where we largely are today, a human using an AI research assistant to code faster. Level 2 is where the industry is aggressively heading right now. A human directs an AI researcher, which then runs experiments to create an improved AI researcher. And then Level 3 is the strongest form of true recursion, an AI researcher designing an improved AI, which then independently designs an even better AI, with humans sitting entirely at the overarching governance level. Section 4. Promises and Real Risks, the Future of RSI. Let's look past the sci-fi scenarios and focus on the grounded reality of what happens next as we move further down that spectrum. The promise here is massive. By automating the AI research loop, we open the door to fundamentally accelerating progress across all of science and technology. If you speed up the rate at which we can experiment, validate, and learn, you exponentially speed up innovation itself. We could solve complex biological puzzles, discover new materials, engineer cleaner energy. The upside is literally virtually limitless. But we absolutely cannot ignore the caveats. Let's see how this builds into specific, highly technical dangers. We aren't talking about Terminator robots here. We're talking about unreliable evaluation. We're talking about reward hacking and benchmark overfitting, basically situations where the AI acts like a student who figures out how to perfectly cheat a multiple-choice grading rubric, but learns absolutely nothing about the actual real-world subject. We're talking about unsafe autonomy and increasingly weak human supervision as the systems get faster. These are the real imminent risks of an AI optimizing aggressively for progress without understanding true real-world consequences. Which leaves us with this final, provocative thought to end our explainer today. What happens when increasingly automated AI optimization loses human context? If the machine is running the loop, proposing the ideas, and validating its own success exponentially faster than we can track, how do we ensure the final product still serves human needs? It's a fascinating, incredibly complex challenge, and one that the greatest minds in AI are wrestling with right now. I hope this really helped demystify recursive self-improvement for you today. Thanks for joining me on this explainer. Keep learning, stay focused, and I'll see you in the next one.